Welcome to this presentation on EvoSkill, which we call the Modular Agent Operating System. Today, we are going to dive into how EvoSkill enables automated skill discovery for multi-agent systems. Essentially, we will look at how we can turn raw AI models into highly organized, structured problem solvers that use discrete, specialized skills, like data processing and model training, to get the job done. Let's start with the current landscape. The great promise of coding agents is infinite flexibility, the idea that they can seamlessly connect to terminals, browsers, and calculators to solve any problem. But the reality? They often have zero domain expertise. General-purpose models use code as a flexible intermediate representation, but flexibility alone just cannot substitute for structured, domain-specific methodology. Without that structure, agents frequently crash, hallucinate, or get overwhelmed by messy real-world data, like the dense U.S. Treasury tables you see here. This brings us to the evolution of how we optimize these agents. In the past, we relied on handcrafted skills, which were highly interpretable but required manual effort, so scalability was low. Then came artifact-level evolution, which automated the process but resulted in opaque, tightly coupled prompts that couldn't easily transfer to new tasks. EvoSkill creates a completely new category, skill-level evolution. It gives us the best of both worlds, achieving the high scalability of automated search without sacrificing the interpretability of handcrafted tools, ultimately unlocking true zero-shot transfer. How exactly does it do this? By operating higher up the abstraction ladder, above the noise. Down at the bottom, tweaking raw model weights requires expensive fine-tuning and causes catastrophic forgetting. In the middle, relying on prompts and execution traces is fragile. They easily overfit and eat up your context window. EvoSkill targets the very top, agent skills. By keeping the base model entirely frozen, EvoSkill builds permanent capability assets rather than relying on ephemeral prompt tweaks. Let's look at the anatomy of one of these evolved skills. Rather than opaque neural optimizations, these skills are tangible, modular assets organized in a simple folder structure. Each skill contains trigger metadata that tells the agent exactly when to deploy the workflow. It has procedural instructions read on demand to save context space, and it uses helper scripts to handle complex math or logic entirely outside of the LLM's context window. The core engine that builds these skills is a three-agent loop. First, an executor agent attempts a task. When it inevitably makes a mistake, the failure trace and logs are passed to a proposer agent. The proposer consults its feedback history and outputs proposed skill instructions to fix the error. Finally, a skill builder agent takes those instructions, writes the actual code and documentation, and commits the new tool to the skill library. To guarantee monotonic improvement, meaning the agent only gets better, never worse, we use a textual feedback sieve. Every time a new candidate program is generated, it is scored against a held-out validation set. If it scores lower than the baseline, the skill is thrown out and routed back to the feedback history so the proposer learns from the failure. If it succeeds, it's permanently retained in the top K Pareto frontier, preventing the base model from degrading over time. This engine effectively turns micro-failures into macro solutions. Imagine the agent makes a micro-failure, like erroneously extracting a value from the wrong cell in a data table. The proposer conducts a macro analysis, diagnosing the root cause as a lack of spatial validation. It then generates a systemic rule, a deployed skill that mandates adjacent cell checks and metric validation. As a result, a single localized failure permanently immunizes the agent against hundreds of similar extraction errors moving forward. Let's look at the hard proof, starting with grounded reasoning on the OfficeQA benchmark, which involves extracting data from U.S. Treasury documents. By applying EvoSkill, we saw a massive 7.3% absolute gain in exact match accuracy, boosting the base model from 60.6% to 67.9%. The key insight we found was that running independent evolution loops and merging the unique skills together actually produces the highest overall performance, proving that different runs surface complementary capabilities. Proof number 2 takes us into adversarial web search using the SealQA benchmark, an environment filled with noisy, conflicting web retrieval. Confronted with the problem of premature search termination, EvoSkill autonomously authored an entirely new protocol. It mandated term interpretation expansion, a minimum of 3 independent sources, and strict enumeration checks. This resulted in an incredible 12.1% absolute accuracy gain. But here is the real aha moment of this research: zero-shot transfer. Because EvoSkill outputs independent, structured assets rather than entangled neural weights, a skill evolved in one environment can be dropped into a completely unseen benchmark and immediately improve performance. We took the search protocol evolved in the chaotic SealQA domain and dropped it into BrowseComp, an unseen factual Q&A environment, yielding a 5.3% accuracy gain without a single manual edit. Under the hood, all of this is managed through Git-backed lineage. We manage the Pareto frontier through simple version control. Each candidate program is just a lightweight Git branch containing only the skill folders and metadata. If a branch fails the threshold, it is deleted. If it succeeds, it is tagged. This architecture provides 100% reproducible snapshots, treating agent memory exactly like a scalable, reliable software repository. To summarize, EvoSkill is not an optimizer that tweaks a model's internal weights, it is a capability factory. It takes textual failure logs and raw compute in the input stage, processes them through our 3-agent loop, and outputs standardized, portable skill modules. Ultimately, EvoSkill solves the transfer learning problem for coding agents by manufacturing interpretable, interoperable intelligence modules. Looking ahead, we are moving from monolithic agents to an open, modular ecosystem of discoverable expertise. This universal skill ecosystem will expand cross-modality to encompass vision and physical actuation. We aim to create open libraries where skills evolved on specific tasks can be shared globally, enabling agents to continuously accumulate knowledge across entirely different software environments. Thank you for watching.